Hello, and thank you for joining me today as we discuss and continue discussing electrons and atoms. So, we talked about electron configuration in the last video. Today, we're going to expand that a little bit. We're going to talk about what are called orbital filling diagrams. And so, Hund's rule in regards to electron configuration was you had to fill an upspin and a downspin. Um, each one had to be single occupancy first. That's going to make sense today when we talk about orbital filling diagrams as opposed to electron configuration. So at the end of today's video, you'll be able to draw orbital filling diagrams for elements on the periodic table. And we're also going to look at what is known as noble gas notation for elements, for electrons. And you'll be able to write the noble gas notation for electrons of elements. So let's get started. To begin, we're going to review our electron configurations. So arrows, in this case, orbital filling diagrams, we have arrows represent electrons instead of just numbers. So to start with, I want you to write the electron configuration for phosphorus. So if you need to draw the electron hotel, please do so. But phosphorus has 15 electrons. And so I'm going to start from the top. We're going to start 1s orbital, holds 2 electrons total. I can do that. After that's 2s, holds 2 electrons, so I'm up to 4 total. After 2s comes 2p, which holds 6. I still don't have 15 yet, so I can keep going. 2, 4, and 6 is 10. After 2p comes 3s, which holds 2 electrons. So now we're up to 12. And then next is 3p, which holds, so I had 2, 4, 6 plus 6 is 12. I need to get to 15. And so 12 plus 3 is 15 electrons. So all my electrons are accounted for here. Now, when we do orbital filling diagrams, we're going to fill a room for each orbital, or each energy level. So I have a 1s orbital. Remember, each orbital can hold 2 electrons. 1s can only hold 2 total, so I only have 1 room. The first one I fill has to be the upspin. The second one needs to be the downspin. So 1s, I filled upspin, downspin, because 1s is full. 2s holds 2 electrons. I'm going to fill an upspin, I'm going to fill a downspin. 2p has, remember, 3 suborbitals, or 3 orbitals, so I need 3 rooms, essentially. We have to fill single occupancy first, and then we double up. So I'm going to fill 1, 2, 3, and I'm going to go back, I'm going to do 4, 5, and 6. So I'm past 2p. 3s only has 1 room. Fill it up and fill it down, and then I have 3p. So because it's the p orbital, they have 3 orbitals within them, so I need to fill the up spin electrons first. So designate the ups first. So 1, 2, 3. And this should match your number up here, because that's 3. I have 3 arrows. I am done. This is my orbital filling diagram for phosphorus. That's how that's going to look. You're going to do a lot of this. It's a lot of drawing. I apologize. But it's not anything you can't do. All right. So if we have unpaired electrons, if we have electrons that don't share an orbital, for example, these last 3 did not share an orbital. They had a room to itself. We call these guys unpaired electrons. And these are the ones that then want to pair. So valence electrons in the outermost energy level, which is your s and p orbitals. And if they're unpaired, that means they don't have a roommate. In some cases, they would like a roommate. So here's carbon. Let's do our orbital filling diagram for carbon. So carbon has an atomic number of 6, which means I have 6 protons and I have 6 electrons. So starting at the bottom, I have the 1s orbital, which holds 2. So I have an up and a down. My 2s holds 2, up and down. So this is, each arrow is an electron. So 1, 2, 3, 4. I need 2 more. This is going to be an up, and this is going to be an up. And now I should have 6 arrows. So 1, 2, 3, 4, 5, 6, which should match carbon. What atoms want to do is they want to have a stable or full outer shell. They want to be stable and have a full outer shell, which is their s and p orbitals. So your 3s, your 3p. If you add these together, we want this to be a stable number, a full number, which should be 8. So they can have up to 8 valence electrons outside of helium. Helium only has 2 because it's in the first energy level and there is no s orbital. So helium is stable with just 2 electrons there. And since we know that, let's look at this. What element would this be? So if I could look at my orbital filling diagram, I can say, okay, I know some things. I know that I fill up to 3 energy levels. So I can be in the third row. I know that my third energy level is full, which means I need 6 electrons in the p orbital. So I'm going to be found in the p block, in the third row, and I should fill my p orbital. And then lastly, I can count them. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Find element number 18. It should be in row 3, and it should be the last element in the p block. It should be on the far right side. And you'll find that element is argon. There. Okay, so we've talked electron configuration, we've talked orbital filling diagrams. The last little bit is instead of writing all of this out for your electron configurations, so instead of writing, in the case of argon, 1s2, 2s2, 2p6, 3s2, 3p6. Instead of writing all this, we can do what's called noble gas or core notation. I call it noble gas notation. And what you do is you go up one row on the periodic table and all the way to the right to find the nearest noble gas. So in the case of argon, we're going to go up a row. So we're going to be in the second row. We're going to go all the way to the right to get the noble gas. Noble gas above argon is neon. Neon has an atomic number of 10. Okay? And so 10 of these electrons can be taken out. And I can write this as neon here. And that's going to eliminate everything that neon encompasses. So neon's noble gas, or neon's electron configuration is 1s2, 2s2, and 2p6. That should be neon. So instead of writing this, I can write in brackets neon, which means all I need to put afterwards is 3s2 and 3p6. So I can put any 3s2, 3p6. This is noble gas notation. All right, now, looking at what's on your screen. To jump ship a little bit, I apologize for the jumping back and forth on this. Looking at this situation, looking at this element, what element do I have here? If you want to count the electrons, you may. If you want to look, you want to say I'm in the third energy level, I'm in the p orbital, and I'm here. You can do that, but you should look through this. So write your element name. I'm going to give you all this on the next slide. So if you do this, you should find this element, I believe, is silicon. Okay. After you have silicon, you should find your electron configuration. Write the electron configuration for silicon. And if you're given the orbital filling diagram, it's really easy. You're just writing the simplified version. So I start with 1s. I have 2 electrons, 1s2. I go to 2s. I have 2 electrons here. I go to 2p. There are 6 arrows, so 2p6. Next is 3s. I'm at 3s2. And my last one's 3p. And there are 2 electrons there. Now, noble gas notation. On your periodic table, find silicon, go up one row. You should be in row 2. Go all the way to the right and find your noble gas. This one should be neon. Again. So again, neon takes up 1s2, 2s2, 2p6. Everything from the previous energy level. So I should have neon, and I should have 3s2, and 3p2. That's my noble gas notation for silicon. And if we look at this, there it is. And we will do more practice with this, but here's a chance for you to do some practice on your own. So with these four, I would like you to do the electron configuration, the noble gas notation, which is what we just did, and the orbital filling diagram, so the arrows, for these four elements. So pause the video, complete those, and then I will give you the answers outside of the orbital filling diagrams on the next slide. So these are your answers. Again, I didn't do orbital filling diagrams because it's a lot of drawing, a lot of arrows. But if you want me to check yours, I can when you return to class. But these are your answers for your electron configuration and your noble gas notation here. Thank you for sticking with me through this video, and I look forward to continuing this unit and this semester with you in chemistry. Enjoy the rest of your day, and I will see you later.